Well, here we are. You, me, rest of the gang. Continuing on. It's a Stickman rebuild. It's a straight 6, but there's some minutia in here that we have to go talk about. Gentlemen, this is part 2. Part 1 is a video that just precedes this. I'll make sure to put the link in the comments section or the description below, which I very hardly ever use, but since these two are tied together, that's the only way that we can get Facebook, or not Facebook, but YouTube to understand that the two are hooked together, even though we can tag them the same and everything. So we are working for my friend. He wants to do a light restore on these and make sure that they're all legit and going to work straight. Just to bring you all up to speed if you're catching this out of sequence. Let me grab something here. We call this a prop. And let's prop this up for us all to take a quick look at it. So we got this propped up. I got the ISO gain all set up. We got light flowing right down in the cabinet. Got the camera all set up on the old tripod, and we're gonna slide on in here like we give. And we're gonna learn. The amplifier tells us a story. You cannot hide from the details. So this is a 3-port, 100 ohm, unbalanced, balanced, however you want to look at it. This is the 3-port standard Stickman configuration. I don't exactly know where this style of combiner unit came from. I'm sure it predates Stickman. I call it the Stickman style because he was so notoriously famous for building like this. There's nothing wrong with it. It's just not very efficient, but it works, and it works well. Covered that in a previous video. There's a lot of things that Stick did that, you know, technology moves on, things get better. We figured out how to make things more efficient. So it is what it is. The box still makes watts. So let's go on up here to the 10 ohm smoke indicators. Now, we're going to take a minute and we're going to listen to the language that this amplifier is spitting off to us. If you listen closely with your eyes, you'll be able to hear it say, oh, look at this 10 ohm smoker, and this 10 ohm smoker, and this one, and this one, and we're going to go look at the entire scorched earth area that's right here, and this one here. Let's look at the board underneath the 10 ohm resistors. The reason I want to make a big deal out of this is because people buy stuff off eBay all the time, and eBay is the worst place to buy this kind of equipment. One, because of its cost, and 2, because there's no way to know if it's actually working or not. So the only thing you can do is use your eyes and look, slow down and look, and hopefully the pictures that you get presented with on eBay give you the whole story. I'm a firm belief that this is the only 10 ohm resistor that has not been burnt in this amplifier. So we all know the only reason these little resistors burn up is because of an imbalance. Usually the imbalance comes from, guess what? Transistor being blown. That's right. Everybody's saying it with me out there in YouTube land. So we have to slow down and we have to look. Now, there is a real reason why I like to use the 5-watt smoke generators instead of the 2-watt smoke generators. The 5-watters I use are, you know, flame resistant, fire resistant, and they don't leave the schmick schmew all over everything. But we can tell this one has been burned up, this one has been burned up, this one has been horribly burned up, and so is this one. The resistors that are in here technically are the right value, and they are technically good, that we can tell without pulling them and measuring them. I had one come in here the other day, completely different style of amp, built by a different person, and it had a problem in it. And come to find out, the problem, what it was this had gone to a short. This was wide open, like we'll just randomly pick this one here. We're going to come back and pay close attention to this area here in a minute. But that resistor had gone shorted, but the transistor was still good. So just that little bit of 10 ohm difference was making a huge difference in how that one section was working. So let's look at our lots. This is an OJ This is a 5B. This is a 6I, a 9I or 9-1. This is a 6J, and then a 9A. So let's pull back and let's look at the transistors we took out of the previous video segment. (6J). We know these are fake. The O is wrong. There's just a ton of stuff that's wrong with this transistor once we start getting focused in on it here. There's problems with the foot. And what I mean by the foot is the cut pattern here on the foot, right in here. It's circular, not straight. The Toshibas are straight across. The fake ones have a curve, as you can see here. We know for a fact, backed up by multiple different videos and lots of different tests, these transistors that come out of Taiwan, and these are knockoffs. We can tell by the glue between the cap and the main body. We can tell by the porcelain down here on the bottom of the transistor. It's the wrong color, wrong material make. We can tell by the way the foot is actually assembled. This is flat. This area here is flat. On the real Toshiba, it's got a cant to it. So when you put the screw through the foot, it pushes the center of the transistor down. We know this is a fake. And apparently these 2 amps came from the same gentleman. I bet you they had the 1x2 drive in this 6-pill, which is a whole lot of drive, but that's how they used to do it back in the day. This one pocket has been epically smoked. Look at the inside of this disc capacitor. Look how jet black it is. Let's go look at the other side. And I bet you that capacitor was sitting somewhere in this orientation. We're seeing the same thing go on over here. All jet black here. This whole disc capacitor is jet black. And as we move on, we'll see that this capacitor is also burned on the bottom side of it. And so is this one over here. Now, just because the 10 ohm smokers are bad or they've been burned doesn't necessarily mean that we still have a problem. Like, I'm sure that this disc capacitor here is still good. It's just covered by the epic scorch mark of when that transistor decided to let go. Now, what this guy did is he knew that he had a blown pill, so he pulled the blown pill out and he dropped in this fake Toshiba. Now, we can't keep this fake transistor in here with the rest of these. We have shown on video, on multiple different videos, that the internal construction of the transistor is wildly different than the stock transistor. This isn't open for debate. This is a fact. Okay, this isn't my opinion. These are non-disputable facts, like the sky is blue, the sun is yellow, grass is usually green, and poop smells like shit. Facts. This is an opinion, so this is a fact. The internal structure of these transistors is different than this internal structure, is what it is. So we know we're going to have to change out this transistor before we go any further. The next thing we got to do is we got to look at this capacitor. So look at that capacitor versus that capacitor and this capacitor. This thing is bent. So when he got in here with his soldering iron, he shoved it in this way and he pushed up against this capacitor and he bent it. The other thing is this whole capacitor leg here is covered with thermal compound. You see that white lithium grease that's, or the white, not lithium, but silicone grease. See that? Of course you can't, because my camera's got a horrible focus on it. Okay. The little details tell us everything. Now these other 4 transistors, 5 transistors, are most likely good. We don't know. We're going to have to take this section apart either way. So that's going to be our first precursor. We got to take this transistor out, and then we got to pull its partner out, and we got to see what the beta gain is of this transistor. So we can maybe match it. Maybe I'll have another used Toshiba 2879 to match to this, for this spot, to match that transistor. We've got a beta gain reference, this one, to know what we can put in this hole to replace this transistor. And we've got to either rebend this capacitor, but if I rebend it, I have to disassemble it and take it off the output transformer so we can remeasure it. That's just looking at it. This is visual inspection. This is not testing anything. We're visually inspecting this, you guys, so we know what to look for. The wife and I are going to make stir fry for dinner, and she keeps coming out here. Look at what I found. Look at what I found. Look at what I found. Showing me all the different ingredients we've got. Okay, so let's tilt this down so we can look at the back and have light in here. So our output combiners are longer than the input splitters. Now we're looking in this department back here. That's a little bit better angle. Our relay is floating, so the customer has requested specifically that I replace this. That's not an issue whatsoever. We showed that to you in the last video segment. But what I wanted to show you is this. This tells us a story. This wire tells a story. Something underneath this wire has gotten incredibly hot. Look at how this is put together. And then let's go look at how this is put together. I'm sure you guys can very easily see the difference. Now, what this tells us by looking at this is that the combiner exploded. And everything caught on fire. The little 2-watt resistors that were there completely caught on fire. When they went up in flame. And they scorched the power wire coming into the box, because it comes over the top of the combiner. Poof. He probably went and replaced these with new 10 ohm 2-watters. But once again, because we used our looking eyes, and we figured out that this one transistor is different than the rest, it's going to show up as an imbalance over here, hardcore, and burn up whatever resistors we put on here. Food for thought. So instead of him leaving the resistors in there and them smoking right away, he thought, nah, I'm going to leave these out. Nobody's going to notice those are missing. The amplifier tells you a story. You just got to be able to interpret the tea leaves the right way, I guess, or the pile of chicken bones that got thrown down on the table by the witch lady. I mean, you just got to know how to read the tea leaves right. Everything in this box says used hard, put away wet. The upside to it is this amplifier is very clean for the most part. So this will be a relatively easy fix for the most part. Pop transistors out. We're going to beta gain this one. Now the other little bit of knowledge that we're going to get by beta gain testing this one is this going to be an indicative barometer for the I'm using these fancy words. If we pull this transistor out and it tests good, that is going to tell us that most likely these other 4 are also still good. But we got to ask ourselves why this one keeps failing, because it has failed several times. You can tell the scorch marks here have been epic. Here and here multiple times. This one is discolored by far. So I'm a little curious, but if we have more than one pop transistor, we're going to HG this box, because it's not financially worth it at that point. I think that's where the customer's at with it. He's already like, is it worth fixing? And I'm like, well, yeah, it's worth fixing. It's a Stickman. It's worth fixing. You know? I'm not going to take anything from Stickman, dude. He was a badass, dude. He'd been there, done that, got that t-shirt, wore it long before I thought about trying to pick up the metal. And now that he's gone, I'm not going to sit here and say anything negative about the cat. The guy could build amps. There was no doubt about it. I mean, no doubt about it. So I'm just sitting here, and my customers asked me to not deviate away from this build style, but to do what we call a soft restoration. soft restoration. That means like replacing the power wires and making sure the relay's good and the box actually works. So we're not going to go in here and do huge power wire upgrades. You're not going to see a bunch of huge resistor changes. These are not indicative of Stickman, but I'm going to leave them in here because that's the way it came. He liked using this style. This is straight up, I bought these at Radio Shack. As Radio Shack resistors if I've ever seen any in my life, and I've seen quite a few because it's all I had for access for parts when I was a kid, because that's as far as I could ride my bicycle to go to the parts store to get stuff. Okay, I've talked enough. Let's pull some pills out. Let's check some gains. Let's see what the hell's going on here. Okay. So let's get down in here and let's look at the crux of the nut. Fix the camera in place so it doesn't wobble all over on us here. Okay, so we have our Chinesium knockoff transistor and our legit transistor. They were sitting like this in the amplifier. This is our 1000 puff capacitor that's bent. This portion of it gives me concern, but I wanted to point out to you the very subtle differences between the two types of transistors. Now don't get me wrong, I'm not hating on the knockoff transistors other than they're fake. I wish they would call them a different part. If they had a different part number associated with it, we might be able to get behind it, because they do work, and that's not what I'm getting off on here. It's the watering down, the muddying of the waters, the changing of, they're different. They're structured different, so therefore they're going to conflict with each other. You can't run them in a matched, balanced set, in a push-pull configuration. Like, I can't take this fake part and intermix it with a new part. It's just going to kill the new part, okay? If it had a different part number on it, like if they called it the Toshiba 2880 or 2881 or something like that, we would give these a hard look, and I'd be able to get on board and say, hey, these kick ass. Instead, what this is somebody's trying to capitalize on this 20, 30 years worth of good parts, trying to capitalize on that part number and scamming people out of money. Because people are going to think they can buy these and intermix them with these. You cannot. They're not the same component. So if we look at the off edge of this thing, you're going to see this little cut right here in the bottom of the substrate. That's different. Also, the gap between the lid and the foot is different. Also, the foot itself is completely different construction. If we look right here, you'll see that this tab has got a bend radius to it, okay? And the other thing that we're going to notice is that this tab is flat. It's flat. So when you put the screw into the tab, it's pushing straight down on the transistor, okay? It's not necessarily bad, but it's not the same as a Toshiba. The legit Toshiba, let's look at it from the side angle. It's got a different substrate material here. There's no notch underneath the leg in the substrate whatsoever. This gap that is here, that is between the foot and this pocket face, is different. There's more gap. If we sit and we look at this, you'll see that this foot has actually got a cant to it. You see that? See how it slightly arcs up just a little bit? And why they did that in the Toshiba, this is the detail the Japanese put into this design, is you push the screw in, or it pulls itself into the aluminum heatsink below it, it's going to torque the edge of the leg and it's going to shove it down, thus pushing the center of the transistor down. So you're going to get better surface contact, better heat dissipation this way. And the main way to be able to tell is this right here. This is flat, straight. There's no bend to it. Bend. It's curved. It follows the body of the transistor. This is straight. All the Toshibas were all made with straight. The other thing is this foot is significantly thicker than this foot. Its physical height, like how thick it is taller, much taller. And you'll also find that the base of this foot is actually larger than the base of this foot. So if you get yourself an old school 2879C box, you're going to find that this transistor won't fit in the hole. The hole that was punched out for this transistor is smaller than what this foot is. So these 9 times out of 10 won't intermix. If you have an old school, let's say Fat Boy, old school X-Force, old school Dave made, where they made the hole exactly the size that you need for this transistor, this one won't fit in it. It's the same problem that we're running into the DEIs and the HGs. They're kind of a close swap, but there's subtle differences that make them so that they don't want to interwork with each other. And the internal structure, they might produce the same amount of power, but they don't. The internal structure is such that you can't intermix the two. And I've covered this in many, many, many videos. When you look at, once your eye gets used to seeing it, it's kind of like a tissue box on Grandma's Toyota Camry. You know, you ever notice that if somebody's driving a Toyota Camry, they got to have a box of tissues in the back window, kind of like how Grandma used to do it. Once you see it, you can't unsee it. Every time you see a Toyota Camry, you're going to look, oh shit, there's tissue in the rear window. Don't know why. It's the worst place in the vehicle to put a box of tissues, but it is what it is. It's the same thing. Once you get your eye trained to look for the details, like the O in the Toshiba is wrong. It's just wrong. It's like a 0. It's not an actual legit O. You'll see the font style is different. Hell, you'll see that the color of the lid material is different. At a quick glance, you'd never notice. But once you get your eyes used to seeing the details, you can tell. I mean, that's why I was able to pull that 1x2 apart yesterday and just quickly look in there and be like, oh, look, those are all fakes. The first thing I always go look for is this right here in the foot. If this is rounded, then I know that the transistor came out of China. It didn't come from Japan. For a long time, these knockoffs, they had too short of leads on them. The lead length was too short. Now, if you want to get out a set of micrometers, or calipers, not micrometer, well, I guess you could measure it with a micrometer. If you want to get a set of dial calipers, you can measure the thickness of the leg, how thick the leg is on the real Toshiba, and then go measure the thickness that's on this transistor, and it's thinner. I mean, there's just a lot of details, a lot of little details. The glue. If we look at the glue that's holding down the lid, you'll see that this is like bone-ass white, right? This has got a little yellow tint to it. This will always stay white. This glue here was either a white or almost a clear, but as soon as you used it or the transistor experienced any heat, it would discolor itself. You'll also notice that the bottom substrate of an original Toshiba is smaller than the cap that is sitting on top of it. There is a defined lip that is right here in size difference. This transistor, the bottom cap and the top cap are the same size. A lot of little different details, but this is bogus as fuck. I don't care who you are, it's knockoff, it's a fake. It's like a Gucci bag, but not. It's made in wherever. Okay, let's take not the absolute transistor tester, but still good enough to get the job done for us to be able to figure out what we got to pair with this transistor. Let's take this transistor and let's put it on the old Atlas DCA Pro DCA 75A. Let's turn it on. Let's see what we get as results here. So it's pretty low. It's got a gain of 6. Gain of 6. Gain of 6. Now, what'll be interesting to me, that transistor's good. That makes me feel a little bit better about the other transistors that are in the amp still. The legit Toshibas. And I'd love to do a comparison, a head-up comparison on this part. I'm afraid to do it, though, for a lot of different reasons. One, I know everybody's paying attention, okay? Not saying that I'm the center of the universe or anything, because I am not. Thank God. But if I go on, I point out a bunch of the other little small details, the people that are copying these are going to change them to where eventually they're going to become, like, from the outside, that's my fear. From the outside, we're not going to be able to tell the difference between this and this. I would assume, okay? I don't want to get on this bandwagon. I don't want to give the thumbs up there. Oh, they're a great part, they work, and go out there and do a test on them and show you what the output tolerance aspect ratio is and hey, these things kick ass because they make more power. I can't do any of that because of the part number. It'll add more confusion to an environment that's already very confused. I cannot tell you how many phone calls I already field over the 2879C and how many boxes are sitting in here that are broken, that were working, where the guy heard that some dude that's told him that some guy heard that you can take the 2879 16D08 HGs and change them out to the Cs and everything's going to work and you're going to get more power. I can only imagine what would happen to the Toshiba market if we gave this a thumbs up in any way, shape, or form. It would be very convoluted and cost people lots and lots of money. So this has got a gain of 57 and it was paired with something that's got a gain of 6. You see my dilemma? I hope you guys can understand where I'm coming from with this. I mean, we've got $200 a piece Toshibas intermixed with a $25 part or a $19 part. I think if you buy them in big enough bulk, they'll sell them to you at $10 a piece, these fake transistors. Still, that 57 HFE gain, that's pretty high considering what we have to deal with the other parts that come from China. So, all that aside, we're going to set this fake ass, this fake gets transistor, we're going to throw it over here with all its fellow brethren. I don't know. I'm just afraid to do that video because I got to be careful what I put my name behind. I really do. And I have to, I found that it's not appropriate for me to have comments on a lot of things because it could be very destructive or it can be very helpful. And I try to reserve my positive endorsement for things that I know are going to work well for the radio world. Like, there was this guy that was in my group the other day, and he started this thread. It was just a bullshit thread. It's one of these threads that you start to be able to talk shit from, is what it basically boils down to in my mind. I mean, the thread was something like, so who builds the most reliable bulletproof box? 2, 4, 6, 8, 10, 12, 16, 24. If this was a legit question, my heart goes out to you, dude. I think that was a good attempt at starting conversation. There was a lot of response on that question, on that thread. You're not going to get me to respond to that because there's so many different ways that my opinion on that could be manipulated. Or it could turn out to be hurtful, or it could be used in a negative way. Do I have my opinions on those kind of things? Of course. We all have our own opinions on those kind of things. Am I going to go out and publicly share it? No. No. I keep those opinions to myself, and I have the right to reserve my opinion. Just like everybody out there in video land has a right to reserve their opinion about whatever they want. Just keeping it real. I mean, I'm just keeping it real. So I came in there and my comment to the whole thread was, I know some guys with the tickle me Elmo emoji where the tickle me Elmo's going, don't know. There's a lot of other variables that come into play with that too. You understand that, let's say I go out and I say so-and-so makes a really, really, really good box. Well, I'm kind of dissing all the other builders by saying that, number one. Number two, there's so many ways that could be manipulated that it's not appropriate by any means. As an adult and understanding where I stand in things in this universe, it's not appropriate. There's just too many ways that thread could be used to hurt somebody, hurt another person's business, hurt another person's income. And I really take pride in the fact that I try not to talk shit. I try to stay above it and stay away from all of that at all times. And it's just my job to fix the box. So unfortunately, I wish we could go look at these, but until they put a different part number on it so it can stand on its own merit, there's nothing I can do with it. There's nothing I can do with it other than to say it's fake. And if you have an amplifier that's got 5 good Toshibas in it, you don't want to intermix the knockoff Toshiba with it because it's a completely different part. As I'm pulling the transistors out, I couldn't help but notice something. We're looking at the solder that holds the board down here, here, the one that's here, and this solder trace back here. The easiest one for you to see is this one here. That thing is cracked as frig. Okay, it's that way on both sides. This is a notorious Dave-made issue. The board flexes up and down. So you're driving around on the road in a mobile and this thing's doing this in the trunk of your car. Boom, 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 boom. The board's doing this. Boom, 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 boom. Well, that little stitch of solder, it's soft, so it's going to flex. Well, we all know from taking baling wire or whatever, you flex it back and forth enough, eventually it's going to break. Well, this is a lot softer than baling wire steel. So all of these stitches, all the way down this side and all the way up this side, are all broken. I covered it in a 1x2 box, and I got to cover it here too. This does not have a board ground to it. This has a nut mount case ground. That's our ground cable. Okay. So that means 100% of our ground has to make its way to the transistors from the case. Well, the more of these that get broken, the less amount of current potential we have to make it onto the board. How else is it going to make it there? Friction, little dolphin tears that are crying out for joy, saying, "Ooh, magically make it over." Unless there's a hard mechanical connection from the case to the board, you have a high resistance point, which means decreased performance and heavier strain on the transistors. Those are facts. It's not an opinion. So we're going to restitch all of these solder joints, probably increase them a little bit in size, but I can guarantee you in 15, 20 years again, that's going to be all broke out as shit again. So it is what it is. We're going to make it work for today. Let's get down in here and let's look at the pill pockets on this thing real quick. And then we're going to go find ourselves a HFE gain transistor of like 10. There was a ton of solder splooge all underneath all the legs, underneath these two transistors. There was just a ton of junk. Little flicks of solder like this, what's going on right here. See that? That's a little flick of solder. Big hunks. The other thing is these pill pockets, once again, held in with drywall screws. Or not drywall screws, sheet metal screws. These are our transistor screws. We try not to use those today because as you're putting them in and you're pulling the screw tight, it'll take and fold the aluminum up around the hole and will cause a lip. And I bet you that's the reason this transistor kept popping. And I can tell you that this pocket's never been cleaned out. Look at all the schmoo that's in the pocket. In between transistor changes, you have to clean all the schmoo out of the pocket and make sure that you have a perfectly flat surface for the transistor to mount to. Otherwise, it's going to run for a hot minute and blow the transistor up because the transistor can't get rid of the heat. So let's go wash this real quick, see if we can get all the burnt schmoo off of here. But in the same breath, I want to show you this too. That is one side of this disc capacitor. It's the other side. We're going to clean this up. We'll knock all this black shit off of here. Same thing on the other one. Burnt as frig. The part's not damaged. It's just the leftover smoke from the non-flame resistant resistors deciding to go up and meet God. Their resistance ability went on to the angels. Went away. Off to resistor heaven it went. I want to show you this before I go and cover it up with schmoo. Let's get as close in here as we can. Okay, so this is proof. This hole here we know had the stock Toshiba in it. This hole here had the Chinese knockoff in it. The guy, whoever changed this transistor out, knew this going in. And look at what he did. He took a Dremel and went with his Dremel bit, and he chattered up the heatsink. That doesn't matter. It doesn't affect us. as much as you would think. That little tiny surface difference there isn't going to make that big of a difference. Most of the contact is made here in the center of the transistor outline. Is it optimum? No. But this is what we had to deal with. And I'm just telling you, this is just proof. I'm showing to you that these chatter marks is making it very clear that they are not the same part. There's no opinion. This is all factual. I got in a debate on Pal Talk the other night with a guy. He's like, well, since with the cost of the Toshiba's coming way down to $25, and we're like, what? What are you talking about? And he's like, oh yeah, they're all over eBay. You can get them for like $21 a piece. Are builders going to go back to using those? And we're like, you mean those Chinese knockoffs? He's like, oh, they're the exact same part. And I'm like, no, they're not. They're completely different. He's like, yes, they are. They have the same part number and everything. Look at the data sheet. Look at the data sheet. Look at the data sheet. I'm like, bro, I'm trying to tell you that you can say data sheet until your dick falls off. At the end of the day, they're not the same freaking component. People that have been in electronics for a long time will live, breathe, fart, and shit off that data sheet. Unfortunately, when I was a young man, back when dinosaurs used to roam the earth, now that I'm starting to get gray in my goatee, back when I was a kid, that data sheet was holy. Man, data sheets sat there right on the top of the TV console, right next to the Gideon Bible. I mean, their word was law, right? Because we had this thing called standards. And I'm not talking moral standards, although that plays into this problem that we're having today. We had a community agreed upon standard that if we had a device, that we would put out its actual operation data freely to other people so that we could have cross-references and we could be able to construct components equally based off of part data. Well, what has happened since the 2000s with the influx of these fake components is people take the data sheet, like go look at a data sheet for a PP100 and then pull up a Toshiba data sheet. We all know that the PP100 is not the same as a Toshiba. We all know that you can't intermix the two parts, but according to the data sheets, you can. That standard to which we all agreed upon is being pooped on by the Chinese completely. They don't give a crap about international standard. There would be a group of people that would have caught that and put that company out of business or made them change their data sheets back in the 80s and 90s. Today, no one cares. No one fact checks anything anymore. Like, nothing. Oh, I read it on the internet. It must be true. Come on. We're all living in that world today where we're overwhelmed with the it makes me sick, gagging reflex of, well, I saw it on the news and I read it on the internet. It's got to be true. And then come to find out 3 to 5 months later when nobody's paying attention, the fact checkers come along and they're like, no, none of this is right. No, none of this is actually truthful. At the end of the day, them are some knocked off garbage transistors with a fake part number on the top. And this is just ever-living burning proof. You can't take that fake transistor and make it fit in that hole. Its foot's the wrong size. The base of the transistor is wrong size. And this is precisely cut to take an actual Toshiba. So, there we go. Okie dokie. So, let's turn that off. Let's go over here. Let's look at this real quick. Hello, 1, 2. Okay. Let's turn the 6 pill back on. That's how much drive we're putting into this thing. Now let's see what we get out of it for power. Hello, audio. About 250. Hello, audio. But what's encouraging to me is my FLIR has died. I've had it on too much the last couple days, and I didn't bother to charge it last night, so I'm lazy. I took a picture of it operating. All 6 of our transistors in this thing are good. Hello, 1, 2, 1, 2, 1, 2, 1, 2. So hitting this with a whopping 20 watts of drive, it's making 300 watts of power. Yay! Woo! BBI. Okay. So, the only thing I got left to do on this now is unplug that. Unplug that. Let's bring this over here. As we're going to pull the power wires out of this, we're going to replace them with new power wires. And then we are going to create ourselves a new three-way combiner balancer thing here in the back. So let me go dig out some more 2-watt resistors like this. We'll get them soldered in the right place. We're going to change out our power wire and change out this shit. And yeah, we're going to get ourselves set up with a Anderson connector here. So give me just a minute. We've got all the sides of this all stitched back together. Transistors are in, transistors are down, everything's cooling itself. It all looks good. Oh, I gotta change the relay. I gotta change the damn relay. Okay, we gotta take 2 on the wrap on this video. Here's the problem that we had. Apparently I didn't turn the microphone on. So here we are. All the previous segments are all loaded in the computer, and I put the wrap on this thing already. So let's reshoot, because I'm a dumbass. Let's reshoot everything I just shot. So as I'm taking this lid off, I want to explain something to you guys. I have cranked out a ton of videos the last couple weeks. This is about my normal work routine. So there's quite a few guys that don't want to have their videos come up public, okay? But I shoot a video for every single thing that leaves here. There's a lot of guys that it just doesn't make any difference to them if they get their video or not. And they don't care. So normally I just shoot them a quick little beginning and end video and none of this commentary in between. I've been shooting videos like this forever, right? I got a system down and I do it real quick. And I gotta start a Patreon channel. I've got to come up with a way to where the videos are actually paying for themselves in the time that it's consuming, okay? And I get asked this quite often, how can I help you? Because I help a lot of people with these videos. And I'm thinking, man, I got to come up with a way to create content just for that channel. I already do it. I'm just not showing it publicly. So for about every video you guys get to see, there's usually 2 others. Well, what if I take and I drop another one of those videos just for Patreon consumption? Even if it's like 1 a week. I don't know. I'm going to come up with something. I've got to create... I got to make this so that the video portion of this thing actually pays for itself. Because it doesn't. It's a giant time consumer. It really doesn't. Okay, so we're going to think of something. This is our 6-gauge wire. This is what we were powering everything with in this amp. It has been the victim of many, many burned, smoky days. This is the wire that crossed over the top of the combiner over here in the corner. And when the combiner let go from the imbalance of this circuit letting go, it spewed out electrical shmoo and it smoked the wire. Well, these two pieces, this is 6, by the way. This is 6-gauge aluminum, power, shock, something or other, garbage. We replaced that with 2 pieces of 8 and a single piece of 4. Of course, everything is hydraulically crimped and soldered. The eyelet and our Anderson clip. Ended up getting a sweet deal on these Anderson clips with the little rubber booties on them. So I bought a bunch of them. It's just something new, something fun, something a little bit different. I mean, the guy's already paying me for the Anderson clip, the power wire, the eyelets and stuff. Why not just go ahead for another $1, give him a rubberized boot to go over the end of his Anderson clip? I mean, for real. Okay, on the Dave Made's on-off, down is on. It's just the way they did it. We got the combiner all rebuilt, brand new relay in here. Of course, all new power wires, everything's reassembled. Let's go ahead and let's run it through its paces. Need the FLIR. First, let's show you drive. So, like I've said in a bajillion YouTube videos, 1000 watt silicon peak, 1000 in average, 5 watt silicon reverse, back from the bird, 10,000 watt dummy load. Right now we're currently on 1X. So 100, we're going to add a 0 to it. Hello, audio. About 180 watts worth of drive. We're going to run that into the straight 6. Let's turn the straight 6 on. Hello, goodbye. Off the scale. Okay, so now we're going to go to 2X. So full deflection over here on the right-hand side is 2,000 watts. So the middle of the scale, which is non-linear, of course, between the 40, the 60, the 20 or the 30, the 10 or the 15, that big hash mark right there is 1,000 watts. The next big hash mark graduated up is 12, 14, 16, 18, and 2,000 watts. That's how we read that. We explained it in a lot of videos. And I mean a lot. Hello, audio. About 1,300 out. Hello, 1, 2, 1, 2. We're going to slide up here. And we're going to look at our input tune. Hello. Hello. It's falling down. That's what we want. Want it going a little bit in reverse, or so stupid low that it doesn't move. That's what we're shooting for. I said under that old Model T. So the whole point behind this is at some point or another, I'm going to come up with a Patreon channel. Probably next month. We're going to start that. I thought of many different ways to make this work. Many different ways to make this work. But the whole point here is to heat the whole box up and make it swing up here just a little bit. And then I want to go and I want to take a picture of the final combiner ring with no heat. Click. And what we're looking at is these 3 resistors right here in the back corner of this box. 1, 2, and 3. If there was any imbalance, any one of these 2 pill sections, this one, or this one, that weren't running uniformly and even, those, it would show up as heat. Now, the other thing that we had to do is we had to take and flip the fan over. For some reason, they had it so it was blowing air this way. So it was pulling fresh air in from the bottom and bypassing all the components and blowing it right out the lid. Me personally, and because of laws of physical dynamics, not opinions, the physical laws of how to pressurize an enclosure, it is easier to put pressure upon than it is to pull a vacuum upon it. So we have direct airflow down on top of our parts, it tumbles around, then it runs to the end of the cabinet, flows across the heatsink, and exhausts out the bottom. Hello, audio 1, 2, 1, 2. 1, 2, 1, 2. If we had imbalance or there was a problem in this box, it would have presented itself as a failure at this point. So, that's that. Let's go ahead and shut this down for a hot minute. The only thing I never cared about these Dave-made cabinets, well, there's a couple different things, but the main thing that I always used to get worried about, because let's get this straight. I mean, I had one of these in my tow truck forever. I had this beautiful medium-duty, light medium-duty Jerdan with a International DT466 train underneath it, 6 in it. Man, that truck, I could pull the universe with that truck. I love that truck. I had a Dave-made 2x4, Joe built, Dave made, underneath the seat of that thing for a better part of a decade. And me personally, the biggest thing that I always worried about, because it happened once or twice, so we'd throw something underneath the passenger seat and we'd bend this grill and it would touch the fan and you go, I hated that. Oh, I hated that. But you run that option, you run into that problem with no matter what kind of enclosure you've got. I always thought that this was pretty neat, this waffle stomp pattern, but it is what it is. Okay, we're going to call this done. I'm going to wrap this up. Gentlemen, I want to say thanks. Thanks to every single one of you for tuning in and following along. I know there's been a ton of content coming out here in the last 2 weeks. I'm over here making moves. I'm trying to get myself set, and I need space. My main motivator is I need space. I'm out of room. I got too much equipment here and stuff is really starting to stack up, and I'm getting ready to go pick up a whole bunch of big, heavy stuff, which is good. Because believe it or not, some of it is going to come to you guys. Some of this stuff is going for sale. Other parts I'm picking up and I'm doing it for repairs. So on that note, I want to say thanks. Guys, you got a question or anything I can do to help you? And that last digit on the number's 8, by the way, but I think everybody knows that by now. A question on something I can help you with, don't hesitate to call. I'm doing the best that I can to get caught up with the workload that has been presented to me and meeting all the responsibilities that I have at hand, and this is just part of it. This is the end of this segment. It's a two-parter, and we're done. All right, I'm jumping out the back tailgate of the airplane. I'm hitting free fall, and I'm going to pull the ripcord, and we're going to call it done for this weekend. Appreciate you guys. I'll see you. Click, click, click.